All right, we're going to wrap up all this naming and formula writing by talking about ionic compounds. Remember, ionic compounds are formed between two molecules that have two different charges. So one's positive and one's negative. So all of the different ways, I put a picture, I think I put this picture in your notes. There are several ways for exactly that you can create an ionic compound. So remember that it's formed when you have a cation plus an anion. Okay, so a positive and negative, and they're attracted to each other by those charges because opposites attract. Okay, you can have this between a metal and a nonmetal. You can have it between two polyatomic ions, which, again, from the polyatomic ion chart, so we'll be like referring to that, a polyatomic ion and a nonmetal, or a metal and a polyatomic ion. And the order is important here. The metal goes first here, and the metal goes first here. And if it's with a nonmetal, the nonmetal always goes second. So metal goes first, is first, nonmetal is second. All right. Now, just a review, I know when we first began this unit weeks ago, I asked you to do a metal and nonmetal sheet. But just as a review, I've also placed this in here. So this picture right here shows you your metals, nonmetals, and metalloids. Okay. So the bulk, a good guess is always that metals, that it's a metal, just because that's the bulk of this. Metalloids are these in the middle, under and above the stairs right here. And then non-metals are all on the right-hand side except for hydrogen, which is over here. Okay, we also know what their charges are based on where they are on the periodic table. I always just start from here, plus or minus 4, and then I know this is minus 3, minus 2, minus 1. This is plus 1, plus 2. Plus 3. All right, so these are the ionic charges. Now, that's what we know here. That's what we know here, but we don't know these. Now, remember, these are, this middle part are our transition metals. And I told you we weren't really going to memorize the charges, and we're not, but I give you options here, 4 or 3, 5 and 4, 3 and 2, and it could be one of those two things. So we're going to kind of work through these transition metals because we are going to have to use these transition metals in our ionic compounds. So some transition metals form more than one cation with different charges. So if you look at iron, you see iron can have a 3 or a 2, but they're both an cation because they're both positive. Okay. Then you will see that group 14 metals also can form a couple of variations right here. Plus 4, or plus 2, plus 2. Okay. And we're going to get into that in just a little bit. And I just also wanted to remind you of your polyatomic ion chart because we're going to be using this like crazy. All right. So how do we name these ionic compounds? First of all, we're going to name the positive ion. Okay. Now, the positive ion is either going to be a metal or a polyatomic ion. Okay. So we are going to name the positive ion first, metal or polyatomic ion. Then the negative ion is either going to be a non-metal or a polyatomic ion. Okay. The negative one is not going to be a metal. Okay. So for a non-metal, we're going to use its name, and then we'll just add IDE at the end. So like chloride, for instance. Instead of chlorine, we'll have chloride. For the polyatomic ion, we're just straight up going to use these names right here. Okay? All right. So again, name the metal or the polyatomic ion. So these are our positive ions with its name. Now, for the last name, so this is the first name. This is the first name, and this is the last name. And the last name is either going to be IDE with a non-metal or the whole polyatomic ion. Now, if the metal up here is a transition metal, we have to assign, or we should assign, a Roman numeral as the middle name. So what even does that mean? Ionic compounds that contain, this is transition metal, by the way. Ionic compounds that contain a transition metal must have a Roman numeral to indicate the charge of the metal. So the transition metals are those elements in groups 3 through 12, which I already showed you, and ones that are under the staircase in 13. Okay, and a Roman numeral is going to be added kind of in as a middle name. So first of all, I thought maybe you guys wouldn't know what a Roman, oh wait. So you determine the charge of the transition metal by working backwards in the formula. And there are two exceptions: silver, which is a +1, and aluminum is +3. These are always the same. So silver and aluminum are always this. And so you don't have to add a Roman numeral. But all the other transition metals, you will need to add a Roman numeral to. These are Roman numerals. So number 1 is just a big, like an uppercase I. 2 is 2 of those I's. 3 is 3 of those I's. And here's where we get tricky. 5 is a V. So if you look here, I think of it as I minus V. So 1 minus 5 is 4. And then this is V plus I. So so 5 plus 1 is 6. So we won't go above 6. So these are the only Roman numerals that I care that you know. All right, you know the charge on the anion because of where it is on the periodic table, or it is a listed charge on the polyatomic ion sheet. So then you're going to look at the subscript on the nonmetal or the polyatomic ion. If no parentheses, then there's only one. So remember, we just assume that if we just have one polyatomic ion, there won't be any parentheses, because it'll be like CO4, and then it'll be a parentheses and then a subscript outside. This means we have 2 of this one, right? We have 2 of those. But if we just have CO4, then it's just understood that we just have 1, okay? So then you are going to multiply the anion charge by this subscript. Okay, this is your least common multiple. So then divide the least common multiple by the subscript on the transition metal, and this is going to tell you the Roman numeral. So it sounds hard, but it's not. We're going to work through it, and I'm going to do a few examples for you. All right, so first, easy peasy. We just have 2 different elements here, right? We have a metal and a nonmetal, Na and Cl, okay? So Na, none of these have any subscripts, which means it's understood to be one of each. So the cation is sodium. The anion is chlorine. So all we have to do is say sodium. That name stays exactly the same. And then the ending, we just take off the ene and add IDE. So it's sodium chloride is your answer. All right, now here we have 2 polyatomic ions, this one and this one. All right, so we would go to our polyatomic ion chart back here, and we would look them up. All right, so we can see what is the anion and what is the cation, what is the charges on each, etc. Okay, so the cation is ammonium, that's this, and the name is in the chart, it says ammonium, and then the anion is nitrate. So literally all you have to say is ammonium nitrate. That's it. Okay, and both of those words came off the polyatomic chart. Okay. All right, another example. We have a metal, iron, and then a polyatomic ion right here. So go back to our polyatomic ion chart and we'll see that SO4 has a -2 charge. Now, there's no parentheses. I added those there, and I should take them off to avoid confusion. So there's no parentheses, which means there's no subscript. So there's only one SO4, okay? So 2 is your lowest common denominator because that's the charge, okay? If, let's say, this was SO4 2, and we also knew that it had a negative charge, our LCM would be -4 because multiply 2 times the charge, which is -4. And there is only one iron. See, you know that because there's no subscript here. So there's only one iron. So when you divide by 2, you get 2, or when you divide 2 by 1, so I'm dividing this charge by this subscript, which is 1, then I'm just going to get 2. So that means that iron has a number 2 charge. So it's iron 2, our Roman numeral 2, sulfate. That's it. Okay. So this I got from the chart, guys. This I got from the chart. All right. Again, this is 2 polyatomic ions, but this time we have these parentheses that show us, well, this is actually not a polyatomic ion. This is iron again, but this has a 3. So again, we know SO4 has a -2 charge and that there are 3 of them. Okay. So 3 times 2 is 6. And that's your lowest common, the lowest common number or whatever. All right. Now we have 2. Now this time we have a subscript of 2 for iron. So there's 2 irons. So when you divide 6 by 2, you're going to get 3. So this means that iron will have a +3 charge. So in this case, it's iron 3 sulfate as opposed to iron 2 sulfate. All right. So pause the video and get to practicing. So here are your answers here. Just a couple of things. How did I get this? Well, I know that this has a -2 charge. So anytime I see oxygen, I have a -2 charge. So the charges have to match. And in this case, manganese has a +2 charge. So those kind of go together. Okay. Chlorine here has a -1 charge. 1 times 2 is 2. And barium just happens to have a +2 charge. So we're even there. This other one down here, -2 charge for oxygen. 2 times 5 is 10. 10 divided by 2 is 5. And so that's why this guy's got a 5 right here. Again, -2. And this guy is a +1, so we have to indicate that this is a mercury 2, and so on and so forth. All right. So here we are. In order to write the formula for an ionic compound, you have to balance the charges. So the charges are going to be balanced because no compounds can have an overall net charge, or all compounds must have an overall net charge of 0. So you know this because we were doing that earlier when we were writing them. We were adding up the charges and making sure that everything matched up so that we ended up with a 0 charge of the overall compound. So it's the same process we discussed for formula writing for acids, except the cation's charge is not always as it is in acids. So for group 1, group 2, 13, 14, 15, 16, 17, we've already gone over this. This is the periodic charge, or you're going to look on your polyatomic ion chart, okay? For polyatomic ions, the charge is given on the reference sheet. The charge of the transition metal is given by the Roman numeral, and subscripts won't have a charge. So they won't be shown if it is 1, obviously, and the subscripts will be the smallest ratio possible. You won't have like 6 and 2, right? You're going to make that the lowest common denominator. All right, so example, sodium sulfide. They give you sodium sulfide. So it has 2 elements in it, sodium and then sulfur. So sodium is a +1 charge. Sulfur is a -2 charge. So sodium and sulfur, you have to use the least common multiple, which basically means you need 2 positive sodiums for every 1 negative sulfur. So you should have Na2S. All right, because you're basically just taking your charges and make sure that the positive, either metal or polyatomic ion, that charge matches equally with the charge of the nonmetal or the polyatomic ion. All right. All right, CaCO3. So CaCO3, when the charges are the same number, they can cancel each other out. So like in this one, if you have calcium carbonate, Ca is calcium. Carbonate, this is from your polyatomic ion chart. You know calcium is +2 from the periodic table. You know carbonate is -2, so you just smush those together because they are both equal in charge. Aluminum oxide. So if I'm given aluminum oxide, I know that aluminum has a +3 charge and oxygen has a -2. All right. The least common multiple is 6. It's easy to multiply those two together. All right. So 3 divides into 6 2 times, and oxygen, 2 divides into 6 3 times. So this is a little more complicated because now you have 2 subscripts, Al2O3. So that just, all I can say is make sure you know the charges and get those charges even, however you have to do it. All right. Strontium phosphate. Strontium is a +2. Phosphate, again, polyatomic ion chart, -3. The least common multiple here is 6. So 3 divided by 6 is 2. 2 divided by 6, or 6 divided by 2 is 3. So SR3, PO4, 2. And remember your parentheses here. All right, so this one, we know that chromium has a +3 charge because it says so right here. That's what our Roman numerals are for. So the common multiple between 3 and 2 is 6. Again, so just do that whole multiplication. The only thing I wanted to show you here was just that the chromium 3, that's how you know the charge is 3. And sulfide, you know the charge of sulfur from the periodic table. So you can figure that out from there. All right, here is your practice. So pause the video. Time to check your answers. I went ahead and put the charges on here. So if it was just a metal, I got that from the periodic chart. If it was a transition metal, then I got the information I needed from right here, right? And then if it was a non-metal, I got that from the periodic table. If it was a polyatomic ion, I got that information from the polyatomic ion chart. Okay, so just double check your answers and make sure that you understand how to do this.